Okay, in part 12, question 12, part A, it's asking us to define effectively a hypothesis. Technical definition of a hypothesis would be a statement to be tested which concerns a population parameter. What that means really is, although you use a sample statistic to help you decide whether or not to reject or accept the null hypothesis, when you then do reject the null hypothesis, you're doing so for the whole population of things involved. So when you roll the dice that you think is biased, you might do it 10 times. That's going to give you a sample statistic to work with. But your conclusion, maybe, for example, that the dice is biased, that conclusion that would then refer to every other future time that that dice is ever rolled, the dice will be biased. So it's not just focusing on the 10 rolls that you use to make that decision. The conclusion actually then refers to every single roll of the dice you ever make. Okay, in part B, it's asking us to define a critical region. Now, there's various ways to defining this, but in essence, it's some range of values, the range of values which would result in the rejection of H0. So you need to get that sense that it's a region which would result in the rejection of H0 and or the acceptance of H1, the alternative hypothesis. Okay, in part C, the context here is that the candidate, Mrs. George, is claiming that 45% of voters would vote for her, and a poll of 20 voters was taken. So in our binomial distribution, then we're going to use n as 20, and because 45% is what she's thinking is the same as voting for her, then p equals 0.45 is going to be our null hypothesis, and therefore it's going to be involved in our distribution there. Our alternative hypothesis, well, there's no obvious claim either way, whether it's lower or higher, so I think we've just got to go with not equal to 0.45 and making it a two-tailed test there. Okay, so therefore it's a two-tailed test. Significance level is 5%, and therefore it's 2.5% in each tail. Now, 5 is the value we're given. Now, at that stage, to some extent, there's a decision to make about, are you testing for probability that x is less than or equal to 5 or probability that x is greater than or equal to 5? Well, it's much more likely that it's going to be in the critical region on the low side than it is on the high side. If you think about 20 people and only 5 of them are claiming to be supporting or voting for Mrs. George, we're expecting nearly half of them, so 45% is nearly half of them, we're expecting, well, that's actually 9, so 20 times 0.45 is 9, we're expecting 9, if the test was done lots and lots of times, we would expect the average to be 9. 5 is on the low side of 9, so that's where it's most likely, if anywhere, to be in the critical region. So that then is not an option. Okay. So if you are in doubt at all, as I said, as I've suggested, the expectation there, which is NP, so 20 times 0.5 is 9. 5 is on the low side of 9, okay, and therefore test probability that x is less than or equal to 5 if it's to be in the critical region. Okay, so probability that x is less than or equal to 5, 20, 0.45. Look at our table. N is 20, 0.45 is the penultimate column. Less than or equal to 5, get my ruler. Now 0.0553. Now 0.0553 is clearly greater than the 2.5%, so greater than 0.025. Okay, and so it's not unusual enough to be deemed critical. Therefore, 5 is not a critical region. Okay, therefore, there's insufficient evidence to reject. H0. Therefore, we can broadly say that we're accepting, Mrs. George's claim that 45% will vote for her. In Part D, we're told that n people were selected in a sample now. Still about Mrs. George, so we've still got a probability of 0.45, and in fact we've been told the null hypothesis is that p is 0.45. This time we're told the alternative hypothesis is that p is less than 0.45, basically saying that Mrs. George is being overly optimistic about her claim, and that therefore people are genuinely doubting whether she's going to get as much as 45%. Okay, it's a 1% significance level, and we've got to try and find the smallest value of n for which it would be rejected, so for which the null hypothesis would be rejected. But what we are told is that no one would vote for her out of this sample of n people. So if no one was vote for her, that's no successes, so probability that x equals 0 is what we're interested in. And it's got to be at the 1% significance level, so in order to be rejected then it would have to be less than that 1%. It's a one-tailed test, notice. So because it's a one-tailed test, you use the full 1% here. So what we're interested in finding is n such that probability that x is equal to 0 is less than 0.01. This would result in rejection of H0, the null hypothesis. Okay, now probability of x equals 0, well, we don't know n, may seem tricky, but let's actually look at the formula. So the formula would say it's nc0 times by p to 0, p is 0.45, times by q, the probability of failure, which would be 0.55, to the power of n. Okay. Now, nc0, anything choose 0 is always 1. And if you're not sure about it, just check it on the calculator. Do 5c1, 5c0, 6c0, 7c0, etc. You always get 1. 0.45 to the 0, well, that's just 1. Okay, so 1 times 1. So we're just left with 0.55 to the n is less than 0.01. So how do we find n in this situation? Well, if you think back to pure maths, towards the end of the pure maths section, on exponentials and logarithms, we know that we can pull that down if we take logs of both sides. So if we just take log base 10 of both sides, so the default log there, that allows us to pull the n down to the front. Okay, so we have n times by log of 0.55 is less than log of 0.01. So what we get now going to do is divide through by log of 0.55. However, when you divide and you've got an inequality, what you've got to be very careful about is that you don't have a negative number, or if you do, then you flip the sign. So let's see what log base 10 of 0.55 actually is. So log there, actually got to write in the base 10 in this calculator. Oops, sorry, let me see it there. So log base 10 of 0.55. Notice therefore that comes out as minus 0.2596, etc., etc., and that's because this value is less than 1. So that comes out as a negative number. So therefore, when we divide through by it now, we need to flip the sign because we're dividing by a negative number, so we flip the sign. Squeeze that in the bottom of the page there. Okay. So that stage we're going to have to go onto a different page, unfortunately. I'll just restate that though. So then we had n is greater than log of 0.01 divided by log of 0.55. Okay, let's just do that on the calculator then. So log base 10 of 0.01 divided by log base 10 of 0.55. 7.70 ... Okay, so we're looking for the smallest value of n for which this situation, so for which the null hypothesis is projected. This resulted in this statement, so therefore the smallest value of n, n min, will equal 8.